Hello, my dear students. This is Tridip sir. Today in this video, I am going to discuss the very fundamental concept of a continuous function. And the important thing is that to understand this idea of a continuous function, there is a little requirement that you should have some idea of functions and their graphs. And this idea, that is, we have certain functions such as identity function, modulus function, signum function, and all these functions are explained in a very beautiful manner in our class 11 textbook. So I think all of you are familiar with these graphs, with these functions as well. Now, to understand, as you know that the continuous function is a very important topic in mathematics. Particularly, this is the very first time we are learning this concept of continuous function, and this will be used in our career. Okay, so this is very important with respect to mathematics, or you may say with respect to our career. Now, to understand this very fundamental concept of continuous function, we start with some fundamental functions that we have learned in class 11. Let us share my screen. Okay, here we have I have shared my screen. I think you are able to see this screen now. We start with a very fundamental, a very simple function which is known as the identity function. Identity function. And the definition of identity function, it has been already explained in class 11 textbook. Here I want to remind you about the definition. F is a function here from the set of real numbers to the set of real numbers, and it is defined in the form how we define this identity function. We may take y equal to fx, which is equal to x. So this is nothing but the identity function. Now let us recall how we draw graph of linear equations involving two variables. In fact, basically you may see that this is nothing but y equal to x. That is a linear equation involving two variables x and y. And if we go back to our earlier classes, when we started learning how to draw graph of certain linear equations involving two variables, then we can recall that what we did at that time. You just go back to some years early, okay? So what we did that time, so far I recall, first we made a table like this. We take x here, we take y here, and the values of x, as you know, x is known as what? We have two variables now. One is your dependent variable, another is independent variable. Independent in the sense, the x is here the independent variable, that is x can be taken as we wish. We may take 0 for x, we may take 1 for x, then you take -1, next you take 2, -2, as you wish. You are free to take any values of x. So why x is known as the independent variable. And regarding y always depends upon x, right? Y depends upon x, and y will be calculated depending upon this condition, how it is related to x, like this. What is the rule? Okay, which binds y and x. Here you see y is equal to x. That is what? If I take x equal to 0, y will be again equal to 0. If I take x equal to 1, y will be equal to 1. Here it is -1, here it is 2, here it is -2, and so on. Now to get the graph, what to do now? Simply to take the x and y axis and then plot these points. As we know, I think all of you are familiar with this pattern, how to draw the graph. Okay, here we have taken the x-axis and y-axis, that is our Cartesian plane. Let us name it. This one is x. O here is the origin, right? X dash is the negative direction of x-axis. Towards the up, we name it y, that is y will be positive towards upward direction, and towards downward direction we name it y dash, that is y will be negative there. Okay, now as you know, in this this is known as Cartesian plane. Okay, so as you know that this Cartesian plane contains 4 quadrants: first quadrant, second quadrant, third quadrant, and fourth quadrant. And I think now you will be able to plot these points as I have taken. For example, the first point, you see here it is what? 0, 0, right? So you simply plot here 0, 0. This point is your 0, 0. Then you go on plotting all these points. This point is 1, 1, 1, 1. And here it will be what? -1, -1, and so on. So in this way we can go on plotting all these points, and finally what to do? Simply to join these points to get the graph of this function, right? Okay, let us try to join these points like this. And we have seen that the graph here is a straight line. As you know that every linear equation in 2 variables x and y gives us a graph which is always a straight line. So why its name is what? Linear equation, right? So linear means a line. Now see, you observe the graph very carefully, very carefully. Do you see somewhere a break on the graph, or is it smooth? Means, so far I can notice here, if we extend the line on both sides, in the upper side, in the downward side, in both sides it is possible for us to extend the graph. Means we may take x equal to 100. In that case, y will be equal to what? 100. Okay. We may take x equal to -1000. In that case, y will be equal to again -1000, and so on. Okay. So in this way, if we extend this graph, we can notice that this will not have any break on it. It is smooth. Okay. It is smooth. It is continuous. So this is the meaning of continuous function. Means graphically, what does it mean? If the graph of a function is smooth. Smooth in the sense that it should not have any break on it. It should not have any jump on it. It should be continuous. It is not necessary that always we have the graph as a line. It will depend upon the function what we take. Since this is a linear function, y equal to x, this is linear. So we are getting a straight line. If we take some other function, then the graph will be different. But however, whatever be the graph is, the thing is that if it does not have a jump on it, if it does not have a break on it, then the function will be called a continuous function. So this is how we can have the idea of continuous function looking at the graph. Nice. I think you have understood this beautiful example of the identity function. We have, of course, so many functions to explain. Okay, let us take some more example. One more example I want to take, that is the modulus function. This is another beautiful function of mathematics, modulus function. The modulus function. The modulus function, right? As you know that modulus function is also defined from, this is a function defined from what? From R to R, okay? So this is a function defined from R to R, and this is defined as y equal to fx. Notation is what? Modulus x. And the definition is that if x is a positive number, whenever x is positive, we take x. Whenever x equal to 0, we take image 0. And whenever x is negative, we take it is equal to -x. Now I think all of you have some idea of modulus. What it means? Modulus means magnitude, right? It cannot be negative. Now looking at this -x, you might have some confusion in your mind that looking at this -x, a question might be there in your mind that how it becomes negative, because we know that modulus cannot be negative, right? So this -x, you look at the condition there. What is the condition there? That whenever x is negative, then only we take it -x, image -x. Means, suppose that I want to find out the image of, suppose, -5. Let us try to find out the image of -5. Here, what is the value of x? X is -5. You see here, we have taken -5 for x. X equal, this one is x. X is negative here. So since x is negative here, and as we have some idea that modulus function means the magnitude, okay, it's the numerical value. So since it is x is negative here, to make it positive, what should be done? You take the last condition, this one, minus x. That is, you take minus of minus 5, which would give you value 5, which is the modulus of minus 5, right? So this is the modulus of minus 5. This is nothing but the modulus of minus 5. And if it is 5, then nothing to do. 5 is already, it satisfies the first condition, that is x is a positive quantity. So we will take its value as 5. As you know that modulus of 5 equals to 5. And if it is 0, then of course modulus of 0 is 0. So this is known to all. I think all of you know these definitions of modulus function. So this is how this modulus function is defined, and it is very simple. It is a very simple function. Modulus means magnitude. You remember that a modulus function cannot have negative values as images. It may be equal to 0. Image may be equal to 0 if you take, because if you take x equal to 0 there, okay? So if you take x equal to 0 there, image may be 0. But if you take x equal to minus 1, if you take x equal to minus 2, minus 3, minus 4 and so on, all the, if you go on continuing taking all the negative values of x, what will happen? What will happen to these negative values? This function will give us all the positive values as their outputs, right? Means negative values will have positive images. If you take minus 1, then this will have image as 1. If you take minus 2, then it will have image 2 and so on. So this is how this modulus function is defined. Now see, I want to draw the graph of this modulus function, and drawing the graph, we will notice a very beautiful concept, that this function too is a continuous function. Now looking at the graph, first of all, let us try to draw the graph of this function. Then from the graph we will notice that this is also continuous. This will not have any break or jump on it, okay? Now let us try to draw the graph of this function. Okay, let us make a table as we have done in the first example, the identity function. We take a table there. Here also, this one is x, this one is y. Now see, in this definition of modulus x, we have splitted this definition into 3 parts. You can, if you look at this definition of modulus x, let us go back to our earlier slide. Okay, here you see, we have splitted this definition into 3 conditions. First one is what? X is positive. So satisfying this condition that x is positive, so let us take some points where x is positive. We can take, suppose we take 1, right? Next we take suppose 2, then we take suppose 3. Okay, 3 points are sufficient enough to draw the graph. So all these 3 points we have taken, that is x equal to 1, x equal to 2, x equal to 3, these 3 points, these 3 values of x satisfy what? X is positive. So satisfying this positive condition, satisfying this x is greater than 0 condition, we have taken 3 values of x. And as you know that y, what will be y? You just guess. If I take x equal to 1, what should be y? Of course it is y. Very good. It is y. Y equal to 1. If it is 2, then y is also equal to 2. If it is 3, then also it is equal to 3. So there is, I think there should not be any type of confusion in your mind that how we are having these values of y from these values of x, right? Then you go to the next condition, that what will happen if I take x equal to 0. You can look at the middle of the definition, 3 conditions. This is the middle. In the middle, that if x equal to 0, what should be the image of modulus x? It is 0. Okay? So let us take here 0. What will happen to this y? This will be equal to 0. Then we have one more condition. You can notice in the definition that we have one more condition, which is what? X is less than 0. Okay? So here x is less than 0. So we need to take some values of x which are negative. So we start with minus 1, then minus 2 and minus 3. Okay? We are taking 3 points for our convenience. Now see, whenever x equals to minus 1 here, what should be y? Of course it is 1, because you know that negative real numbers will have modulus positive. So minus 1 will have image 1. If you take minus 2, then what should be the image? It is 2. If it is minus 3, then what should be the image? It is 3. So this is very simple to find out this table. Okay, just this table. Now see what is left to obtain the graph. To take the x-axis, to take the y-axis, and finally to plot these points to obtain the graph, right? Let us see how we obtain the graph. This is very simple and this is very interesting. You should not find it difficult. You should not think that all these graph parts are very difficult to understand. If you go to the depth of this graph part, you will find it very interesting, and this will be of course used to solve some numericals which will take less time. Okay, so I will go to that part later on, but right now let us try to draw this graph. Okay, first of all I want to give names of this axis. This one is x-axis, positive direction of x-axis, then origin, then negative direction of x-axis. This one is positive direction of y-axis, this one is negative direction of y-axis. Okay, now we have the Cartesian coordinate plane containing what? X-axis and y-axis, right? Now see, first of all I want to plot these points, right? So first we start with this one 0, 0, this one is 0, 0. Then you go on plotting these positive points 1, 1, say this one is 1, 1. So if you go on plotting these points, what we have is that we will get some line, a line like this here. What we will get? We will get a line like this. In this direction, in this positive direction, we will get a line like this. That is a line. Means on this line, we see that on this line, next point from the table, if we observe that our next point is what? 2, 2. So this point will be 2, 2. Then of course 3, 3 will be there like this. And we can of course go on plotting points like that. We may take, you are free to take 0.5, 0.5. You are free to take √5, √5 and so on. But for our simplicity, we have taken 1, 2, 3 for these positive values of x. And if you go to the negative part, as well, then you will notice that the graph will look like this. Here also you will have a part of the graph like this. Sorry, this one, let me delete this one. Start from the origin. Okay. Now see, on this part, what will happen is that, first of all, if I take what I want to take here from the table -1, this is 1. Okay. So this point is our -1, 1. Then if I take -2, then this point will be your -2, 2 and so on. Now it is very interesting to see that as we have got in the first function we have taken, the identity function, here also the graph is a bit of course different from the last one. But however, here also we see that this graph, it does not have any kind of break on it. It does not have jump on it. On both sides it can be extended, and there is no value of x for which we are not having y. Means this graph is smooth. Means what? This graph is continuous. So why we call that the modulus function is a continuous function. Now I think looking at these two examples, an idea has come to your mind regarding continuous function and how we can relate these continuous functions graphically, right? So these two examples, I will give only 2 examples for these continuous functions. Now let us see how the graph will look if we take a function which is not continuous. The mathematical definitions, how we solve these numericals of continuous functions, all these will be left for our next sessions, next discussions. But right now let us take one more example. Okay, so I think you have understood all about this modulus function and why we say that this function is also a continuous function. Now let us move to some other function, right? We move to another beautiful function in mathematics, which is the Signum function, right? This is known as the Signum function. And one more thing is that all these functions, that is the identity function, the modulus function, the Signum function, all these functions will be required again in our very first chapter, that is the relation and function part. You can remember, I think, that there is one function, there is onto function in our syllabus. So to understand that part also, this definition will be required. So you should not ignore these functions. You should carefully understand, try to understand whatever these functions are. Okay. Now see, this function is defined again. This is a function from R to R. Okay. So this is a function from R to R, and how we define this function? Definition is that whenever, here also I want to split, not I want to split, this is splitted, it is the definition. Okay. This is not that I am saying that this is what I have done. I have nothing to do. I am just following the definition of signum function. Okay. So this is 1 whenever x is a positive quantity. This one is 0 whenever x is equal to 0. And this is -1 whenever x is less than 0. So we have splitted the conditions into 3 parts. First one is that whenever x is positive, the image is 1. Whenever x is 0, the image is 0. And whenever x is less than 0 means what? All the negative real numbers. Okay? For all the negative real numbers, the image is what? -1. Okay. Now, without drawing the table, without making the table, let us now try to draw the graph. This is very simple. As you can see here, the graph is very interesting. So let us give names of this axis. We have taken x-axis and y-axis, right? So this one is positive direction of x-axis, origin, the negative direction of x-axis, positive direction of y-axis, origin, and the negative direction of y-axis. So this is the Cartesian plane containing 4 quadrants, first, second, third, and fourth. Alright. Now we start with this one. You see the middle condition, x equal to 0 implies fx equal to 0 means what? 0 will have image 0. Okay, let us plot here 0, 0 point. 0, 0. Then you go to the first condition. Here we have seen that whenever x is positive, the image is 1. Now my question is that, had it been n, the set of natural numbers, and if I say that x is a positive number, it must start with 1. Means we will have taken values from 1, 2, 3, 4 like that. But this is all about the set of real numbers, and if it is positive number, if x is a positive real number, then there is no starting point. Because if we think that we start with 0.1, you may sometimes think that whenever x is positive, maybe x will start from 0.1. But this is not true. As you know that between any two real numbers, there exists infinite number of real numbers. So we cannot take the first value to be 0.1. Is it clear? Means the thing is here that whenever x is positive, sometimes you may think that x will start from 0.1. But this is not true. This is not true. Why not true? Because between 0 and 0.1, between this 0 and 0.1, we can insert infinite number of real numbers. That is, if I say x is a positive real number, it is not true that x will start from 0.1. Right? X will not start from 0.1 because there exists infinite number of real numbers in between 0 and 0.1. Again, you see, we may think of then if it is not 0.1, then it should be 0.01. We may start with 0.01, right? It may come to your mind that if it is not 0.1, then the starting point may be 0.01. But that is also not true, because using the same justification, same reason, we can say that between 0 and 0.01, there exists infinite number of real numbers, right? There exists infinite number of real numbers. Now see, however smaller the value is, if it is positive, means if you suppose want to take x equal to 0.000000, you insert so many zeros and then you put 1, and finally you are relaxed to feel that okay, we have ultimately got some value of x which is just greater than 0. But unfortunately, it is very unfortunate that still there is scope to insert infinite number of points between 0 and that particular value. Okay? Means from this discussion, what is the summary? You just recall, you just try to get the summary that whenever x is positive real number, there is no starting point. We just take so why. And another thing is that if it is positive, then the image is 1. If it is 1, then image is 1. If x equals to 2, then also image is 1. If x equals to 3, then the image is 1. Means for all positive values of x, the image will be 1. So what we have is that, say this one is 1 on the y-axis. Now what we have is that as graph, what we will have a line like this. We will have a line like this. This is the line y equal to 1, right? So this is the line y equal to 1. But the thing is that we cannot join this line with the y-axis. We have to give a gap here. Now a question may come to your mind that why should we give this gap? Okay, this is already, I think I have already explained the reason. I have already explained why should not we join this graph to the y-axis, because we cannot join. Because if I join, suppose that you want to join, you join this with the y-axis, then what will happen? What will happen at this point? What will be the image of 0, 1? So at this point, what is the corresponding value of x? It is 0, and we are having image 1, which is not given. Now this is contradictory thing, because at x equal to 0, we must have y equal to 0. So why we cannot add this graph with the y-axis, we have to give a gap here. We have to give a gap. Okay, so the y-axis is okay. Now we cannot, again the y-axis is, I want to remove this gap only. Okay, this is done. Now we have to give a gap. It means you take a very small positive real number. In that case, image will be 1. But if you take 0, image will be what? 0. This is according to the definition. Okay, this is not that what I have told. This is just we are following the definition of the Signum function. Is that all right? I think you have understood whatever I have explained, that this is your y equal to 1. At all these values of x, if you take 1, image will be 1. This is 1, 1, 2, 1, 3, 1, and so on. So on this line, corresponding to all the values of x, you will be having what? You will be having all y equal to 1. And similarly, using the same reason, to the in the lower part towards downward, what we have is that we will have one more line like this. This is your y equal to -1. This is nothing but y equal to -1, and we have to give a gap here because we cannot join. You see, the reason is same explanation. I think you will try to understand why I have not explained here in this second part. The explanation is same. Okay, now see, we are done with the graph of this Signum function. We have already obtained the graph of this Signum function. So this Signum function has a graph consisting of this part, okay, that is the line y equal to 1. Then this origin, that is the 0, 0, and to the left of y-axis this part y equal to -1. Now what we have seen, that it is not smooth, it is broken. Now you carefully observe where is the break, where it is broken. You can observe that it is broken at this point 0, 0. This is an isolated point. You see, this is an isolated point. This 0, 0 is an isolated point. Then the rest part of the graph contains this part and this part. Okay, means we cannot see similarity between the previous two graphs and this graph. There is something different. I think you can notice what is the difference. There is something different here. And what is the difference here? That it has a break at the point 0, 0. So from this graph, it is very clear that this function is not a continuous function. Okay, this function is not a continuous function because it has a break at the point 0, 0. Later on in our next videos, we will discuss mathematically how can we prove that this is not continuous at 0, 0. That is another thing. But right now, looking at this graph, we can conclude that this is not continuous at the point 0, 0. I think you have understood clearly. Now I will take one more example, and that will be the last example in this video. I think you have enjoyed a lot. You have learned how can we relate graphically a continuous function, how can we describe a continuous function from its graph. Okay, so let us take the last example, a very simple example. Example, suppose f is a function from R to R, and we define like this: fx equal to, say, I want to split this function as 0 whenever x equal to 0, and this is 1 whenever x is not equal to 0. This is a very simple function, means at the point x equal to 0, the image will be 0, and if I don't take 0, then image will be 1, be it positive or be it negative. It does not matter. If it is positive, then also image is 1, and if it is negative, then also image is 1. So without taking the table, being students of class 12, I think you should be able to draw the graph without taking the help of the table, right? So without taking the help of the table, let us see how this graph will look. Okay, first of all, let us take the x-axis and y-axis. Here I want to take the x-axis, y-axis, as we have already done in the last 3 cases. Then I want to give names of this axis. Okay, so first let us give this is the positive direction of x-axis, right? This is origin. This is the negative direction of x-axis, positive y-axis, and negative direction of y-axis. Okay. Now see, from the first condition, you just look at this first condition, that x equal to 0 when x equal to 0, fx is having image what? 0. Okay. So when x equal to 0, fx is having image 0, means we are having the point 0, 0. So this is the point 0, 0. This is the point 0, 0. And the remaining part, if you look at this second part, the remaining part, whenever x is not equal to 0, what we have is that it has image 1. If it is positive, then also image is 1, and if it is negative, then also image is 1. So I think you just try to get the graph yourself. I will draw the graph like this. This part is your y equal to 1. Here also we will have a part to the left, y equal to 1. Okay, let us. Okay. Then what we will do, we will give a gap here. Means, as in our last example, already we have explained why we cannot join this line to the y-axis. So this is the line y equal to 1. But we have seen, I want to remind you that why we cannot this line with y-axis, we cannot join, because if x is not equal to 0, you just look at the positive direction of x-axis to the positive direction. This is the positive direction of x-axis. Okay, if it is not equal to 0, then x is a positive quantity. And there is no starting point, as I have already told you that there is no starting point whenever x is a positive real number. So we cannot join this line y equal to 1 to the y-axis. And using the same explanation, whenever x is negative, it does not have any starting point. So we cannot join. Okay, we cannot join this line with the y-axis. So why we are having a line y equal to 1, no doubt this is a line, straight line, but there is a gap. Where is the gap? This is the gap. You see, this is the gap. This is the gap. Okay, means what? This is an isolated point. 0, 0 is this point. 0, 0 is a part of the graph, but that is isolated, and the remaining part is left with that particular point x equal to 0 blank. Means this graph has a break at the point where it has a break at the point x equal to 0. So why this is not continuous? It is very simple. It is not continuous. Why not continuous? Because it has a break at the point 0, 0. Means, in other words, it has a break at the point x equal to 0. So this is all about the very fundamental concept of continuous function. We have taken 4 examples. First 2 we have taken to convince ourselves that yes, looking at the graph, we can say the function is continuous because the graph does not have any break or gap. Okay. And in the last 2 examples, in the last number 3 and number 4, we have seen gaps, we have seen breaks on the graph, we have seen some isolated points, right? See, means what? From the graph we can see that the graph is not continuous. So why the function is not continuous? Okay, so this is all about today's session. Thank you. I think you will you have understand whatever I have explained. This is a very interesting topic, and in our next videos we will go on to the mathematical definition, how we define a continuous function. Thank you.